So today we will talk about density. So in the beginning, all of us take an IGCSE, all of you take an IGCSE density, and we said if the object has a density lower than water, it will float. But if the object B, like B, has a greater density, it will sink. Okay, this is what you take in IGCSE. So now we need more details about density. Density is mass over volume. So if we suppose we have same volume, so the object with a greater mass, so for example, this mass is 2 kilogram, but this mass is 10 kilogram, but they have same volume. I suppose this is same mass. No, I have same volume. So which one has a greater mass? Object 2A has a greater mass, so it has a greater density. So what is the density? Density comparison. For 2A, the density is 2, but for B, the density is 0.4. So a greater mass, a greater density. This is why if I place the object 2A in water, it will sink. But if I place object B in water, it will float because B has a lower density, but A has a greater density. So for same volume, greater mass, greater density. Less mass, less density. Okay, this is the first thing about what density and what the relationship between density and mass if the volume is fixed. Okay. Okay, now what if we have same mass? Same mass now, greater volume, lower mass. Greater volume, lower mass. Small volume, high density, sorry. Greater volume. Greater volume, low mass, inversely proportional. But small volume, high mass. So now as you see, for object, this is object A, and this is object B. For object A, we have a greater density. For object B, we have a lower density. So what is the relationship between density and volume? Inversely proportional. Inversely proportional. Greater volume, lower density if the mass is fixed for same mass. Okay, so now let's start writing. So now as you see, when we study density, you take before the equation for density. Density equal mass over volume. So what is the relationship between mass and density? If we have a fixed volume, so density and mass inversely proportional. Directly proportional. So mass and density directly proportional for same volume. So if we have same volume, as mass increase, density increase. But for same mass, what is the relationship between density and the volume? It's inversely proportional. As volume increase, density decrease. Okay, so now density itself for the material, it will be the same. How can we change the mass? For same volume, you need to change the material. So each material has its fixed density. Density is constant for the material. This is why to change density of material, you need to change what? You need to change the type of material. And from this equation, we can write the definition of density. Density is mass per unit volume of an object. object made from low density, so it will have low mass, as I said, for same volume. While, like for example, a balloon is less dense than a small bar of lead despite occupying a large volume. Okay, now the unit of density. What is the unit of density? It depends on the unit of mass and the unit of volume. So now what is the mass unit is kilogram, the SI unit, and the SI unit for volume is meter cube. So we suppose what? What is the unit of density? If we suppose the unit of mass is kilogram and meter cube for volume, so it will be kilogram per meter cube. It can be written as kilogram meter negative 3. Okay. So as you see, more dense has a greater mass. And greater mass because it has what? A lot of particles in this volume. But if we have less particles, it means low mass. So it will be less dense because we have same volume. Also, we need to talk about converting in this part. So, for example, if we want to convert from centimeter to meter, we need to divide by 100. What about centimeter cube to meter cube? It will be divided by 100 cube. Okay, now what about from millimeter to meter? We need to divide by 1000. If we want to convert from millimeter cube to meter cube, we need to divide by 1000 cube. Now, if we have the density with gram centimeter negative 3 and we want to convert it to kilogram meter negative 3, so we need to what? We need to multiply 1000. This is how to convert. So this is a very important converting in this part. Now, as I said, so density equal mass over volume. And if you want to find the relationship between two quantities, the third must be constant. Okay, now let's move to the next. Measuring the volume. How can we measure volume? We can measure volume using ruler and also measuring a cylinder. We can use ruler or micrometer screw or vernier caliper if the object is what? Regular shape object. Okay, so for example, if we have a rectangular cube or a rectangular block like this or a cube, we can measure length and width and the height using a ruler. Then the volume will equal length multiply breadth multiply height. If we have a cylinder, we need to measure the radius. First, we need to measure the diameter. Then radius equal diameter over 2. And if you want to find the volume of the cylinder, also you need to measure the height using the ruler. So volume equal pi r squared multiply height. This is the equation of the volume of a cylinder. Finally, if you need to find the volume of a sphere, we need to measure the diameter of the sphere, then find radius equal diameter over 2, okay, and we can measure diameter using what? Mostly we will use micrometer, or we can use a vernier caliper. Okay. Finally, if you want to find the volume of a sphere, volume of a sphere equal 4 over 3 pi radius cube. So this is the volume of a sphere, and this is very important. So What if the object is a regular shape object? You need now to use another instrument. You can't use ruler because this is a regular shape. We will use a measuring cylinder. We can use a measuring cylinder. You can place water inside the measuring cylinder. Then you can add the object inside it. So what will happen to the water level? It will be higher. The difference will be the volume of object. So now this is how to find the volume of a regular shape object, and also you take it before in IGCSE. Now let's move to the next. Now we have an example. A paving slab has a mass of, so now he gave us the mass. So what is the given? We have mass equal 73 kilogram. And he gave us the dimensions of the rectangular block. So we have length equal 850 millimeter and width has 500 millimeter. Finally, the thickness or height is 40 millimeter, and they asked you to find density with kilogram meter -3. So now we have mass in kilogram, so we don't need to convert, but he said kilogram meter -3, we need to convert from millimeter to meter. So now we need to divide the dimensions by 1000. After that, if you need to find density, density equal mass over volume. So the first thing you have to write the equation. After that, density equal mass over length multiply width multiply height. Finally, mass is 73 and 850 over 1000 will be 0.85 multiply 0.5 multiply 0.04. The answer will be the density, and the unit will be kilogram meter -3. Let's move to the next. So to find the density, it will be easy. Also, you can make the equation in rectangle, so in triangle, sorry. So it will be density equal mass over volume. If you need mass, it will be density multiply volume. If you need volume, it will be mass over density. So you can rearrange as you want in the question. Now let's move to the next. We will talk about upthrust force. Upthrust force is the force from the liquid or gas. We call this flights. Okay, and it will be upward. Okay, so what is the symbol of upthrust? It will be U. U, capital letter, not small letter. So it will be written like this. This will be upthrust force. Okay, and how can we find the upthrust force? We will use what? We will use Archimedes' principle states. What? Archimedes' principle? He said, an object submerged, totally or partially submerged in a fluid at rest has an upward buoyancy force, which is called upthrust force, equal to the weight of the fluid displaced by the object. So we will suppose we have a displacement can like this. We call this instrument displacement can. And displacement can has the water filled with water until the spot. So we have here water or any liquid. We fill it in for liquid until the spot. Okay, okay. And after that, we will place also a measuring cylinder. Okay, here. Okay, so this is measuring cylinder. And we know what is the mass of measuring a cylinder, known mass. For example, it has 100-gram mass. Okay. Now, if we need to know what is the upthrust force affect an object, where is the object? This will be the object. So we have three cases. Okay. So what is the first case? If the object is floating, so if we place this object in the liquid, as you see, some of the object will submerge and another part is floating. And as you add the object inside the liquid, a part of the liquid will be displaced. So a part of the liquid will be displaced and fall in the measuring cylinder. Now we need to find the weight of displaced liquid. This is will equal what? Upthrust force. So to find the upthrust force, you need to weight or to know what is the weight of the displaced liquid when you add the object. Okay, this is why we can write U equal weight of displaced liquid, and as you know, weight equal mass multiply G, mass of displaced water or displaced liquid. And as we said, mass equal density multiply volume. So we need to replace mass with density of liquid multiply volume of liquid displaced multiply G. And of course, what is the volume of liquid displaced? It will be the volume of submerged part. So now VL equal V submerged. Okay, part of the object. Okay, as you see, I can show you an example now. So now we have two objects, for example, this object, and we want to know what is the weight of the object. This is 45.1. So as you see, the weight of the object is 45.1 Newton in air. What happens when we place it in a liquid? Okay, so now as you see in the right side, the density of the object is what? 0.92. So the density of the object is less than the density of water, and you have to know what is the density of water. It's equal 1, and I said the fluid here is water. So as you see, as the object density decreased, what happened? The volume submerged of the object submerged under water, under surface of water, will decrease. Okay, and also as you see, every time the density decrease, so the volume under the surface decrease. Okay, and as you see, weight equal 27 Newton, and also the buoyancy is the upthrust force equal 27, because the object is floating at rest, so force up must equal force down. So we have two types of forces, the weight downward and upthrust upward. Okay, and resultant force of course will be 0. What if we increase the density? As you see, we still have weight downward equal upthrust force. But what happened? The volume of the object submerged under the surface of the liquid increase until the density of object now is equal the density of liquid. Now the volume of the object equal the volume displaced of water, and the density of object equals the density of water. Okay, and until now weight equal what? Equal upthrust. Now, what if the density of object become greater than 1? The object will sink. Now, we have three forces. Weight will be greater than upthrust force because we have another force which is called reaction force. Okay, reaction force from the surface upward. Okay, so this is reaction force. Okay, so now as you see, weight becomes greater than upthrust force. So now I will return to the page to explain the three cases. So in fact, we have three cases now. What are these? We have, first, we should know that upward force, which is upthrust, U equal weight of the liquid displaced. And as I said, weight equal mass multiply G. And mass of liquid displaced equal rho of liquid multiply V of liquid displaced multiply G. And as I said, what is G? What is VL? Submerged. Okay, now let's move to the next. We have three cases. We have three cases. What is the first one? If the object floating, if the object floating like this, we have water and this is the object. This is the object. So now the object is floating. Okay. So now this is the VL. Okay. So as I said, because the object is floating, if you want to draw the force diagram, you need to draw weight downward and upthrust force. And weight will equal upthrust. So now weight equal upthrust. Okay, now upthrust equal what? As I said, rho liquid multiply V liquid multiply G. And weight of the object will equal rho object multiply V, total V for object, the total volume, multiply G. We can cancel out G. What it means? It means we can find a relationship between rho, density of object with density of liquid, with volume of object and volume submerged. So volume for liquid can be equal density of object over density of liquid multiply volume of object. Okay, so now the volume of liquid displaced, which is volume under the liquid surface. You have to know this is the volume under the surface of the liquid. Okay, and this is the first case. Okay, what about the second? If we want to talk about the second, okay, I will explain the second in this area. Now, what if the object is drawn like this? This is the object. It's in the middle, or it's at the middle of the liquid. It is not at the at the depth, total depth. So now we have the object totally submerged, but it is not at the bottom. It's just at the middle of the liquid. So now we need to draw the forces affect. So for example, this will be the forces affect the object weight and also U. So now also U equal W and rho liquid multiply V liquid multiply G equal rho object multiply V object multiply G. We can cancel out G. Now, because the total volume submerged equals the total volume of the object, density of liquid equal density of object. This is why the object is what in the center or in the middle, okay, in the liquid. So now, density of liquid equal density of object. Volume of liquid equal displaced equal volume of object, total volume of object. Okay, now finally, if the object sink in the liquid, so now I have the object here. Okay, now what happened? If we want to draw the forces affect this object, we need to draw three forces. The first force will be W, and we need to draw two forces, upthrust and normal reaction force. Okay, now weight, it doesn't equal U, it equal U plus R. Okay, so now it means U is smaller than weight. What it means? Again, it means density of liquid will be smaller than density of what? Of object. Okay, we can talk about what? In this case, we can talk about the volume, okay, because volume of liquid is still equal volume of object. Volume of object totally submerged. So volume of liquid displaced equal volume of object. This is why, because W weight of object greater than water weight displaced or liquid displaced. So this is why density of object must be greater than density of liquid. This is the three cases for this part. Okay, now let's move to solve this question. So this is 2 and this is 3. He said in this question, icebergs typically float. So now he said float with a large volume. Float, what it means? It means U equal W. On ice spent the water. Ice has density of, so we have density of ice. So this is the density of object. Okay, and the volume VI. So this is the total volume of the object. The density of seawater. So this is density of liquid. What is the fraction of the iceberg is above the water. So now this is the question. We have liquid like this. Okay, the density of liquid, which is water, is 1020, and also we have an object. Okay, and the total volume of the object, the total volume is VI, and he asked to find what is the volume above the surface. In fact, you can't find the volume above the surface directly. You can only find VL, the V of the object under the surface. And as I said, if you want to start from the beginning, because the object is floating, U equal weight. So now, rho liquid, V submerged, multiply G equal rho object, multiply V object, which is VI, multiply G, cancel out G. So now we need VL. VL is the volume under the surface. Will be rho object multiply VI over rho liquid, which is equal 917 multiply VI over 1020. It will give you 0.9 VI. Now we need to find what is the volume above the surface. We can subtract volume above equal VI minus 0.9 VI. So the rest will be 0.1 VI. This is why A is the correct answer. Now let's move to the next. Now we'll talk about Stokes law. What's Stokes law? Stokes law state what? Now, if we want to talk about Stokes law, we need to define a viscous drag, which is drag force. And what is the symbol of drag force? FD, or you can write it as D, which means drag force. Drag force similar to the frictional force. But we said drag force like air resistance. It's a type of friction force, but between what? Between the object and the fluid, liquid or gas. In case of air, we said air resistance, but in case of a liquid, we will talk about not air resistance or water resistance or liquid resistance, we talk about drag force. So drag force is a frictional force between object and fluid, which is opposite the motion between the object and the fluid. So every time you need to decide where is the direction of drag force, you have to draw the direction opposite the motion direction. So for example, if we have a tube like this and it has a liquid and the object, this is the object. So if the object is falling, the sphere falling. So now what is the forces? We have, in fact, we have three forces. What are these forces? We have weight, downward, and of course, what is upward force? Upthrust. What else? Because the sphere is not stationary, it's moving. So if it's moving downward, so we have what? Drag force. So now drag force is toward the top. It's upward force. What? But if the sphere is moving upward, it's opposite motion. So for example, now if the sphere is moving, for example, like this, so this is the liquid and this is the sphere, and the sphere is moving up. So now sphere is moving or accelerating upward. Okay. So now, how can we draw the forces affect the sphere? It will be like this. Weight will be down, and also drag force will be down, because every time you need to draw the drag force, it must be opposite direction of motion because it's moving up. The drag force will be down. Finally, upthrust will be up, and of course the size of the arrow of the upthrust must be greater than weight, because it equals weight plus drag force. So now you can draw the fixed direction of weight is always down, and for the upthrust it always upward. But if drag, it will depend on what? The motion direction of the object. Okay, now how can we find the viscous drag force? The viscous drag force Fd equals 6 pi eta Rv, and this equation will be given. So now, what is the equation given for you? He will give you F drag force equals 6 pi eta Rv. So F is the drag force, and it will be written as F or Fd. And eta is coefficient of viscosity. We can call it viscosity. and the unit of viscosity is ns meter, -2, or PAS, Pascal, multiply second, Pascal second, okay? And r is the radius of the object in meter, and velocity v, terminal velocity or velocity, will be meter second minus 1. Okay, this is the velocity. So now if drag force equals 6 multiply pi multiply eta, which is the viscosity, multiply radius multiply speed. This is the equation that will be given in the equation sheet. Okay, but pay attention, because thrust force, we take it before upthrust force equation, it will not given to you in the equation sheet. So you need to memorize what? The upthrust equal mass of liquid multiply G, or rho liquid multiply V liquid multiply G, or rho liquid multiply V displaced volume, displaced, okay, or we can say under the surface, okay, so we can write it as under the surface, okay, submerged multiply G, okay, so you need to memorize this equation. It will not be given in the equation sheet, okay. Now let's continue. Okay, so now we have finished this part. I need to add something important to you. Now we want to, the unit of eta is what? We said PA second, or Newton meter -2 second. Okay, so we call this, we said this is the unit of the viscosity, eta. What if we want to make it in the SI base unit? SI base unit, which is kilogram meter second. We want to convert this because we have Newton. So now, we said before, what is Newton equal? We said Newton is kilogram meter second minus 2, because we said force equal mass multiply acceleration. Okay, so now we will replace n with this part. So now eta, if we want to write eta, again, eta unit is pass, or Newton meter -2, or multiply s. But sometimes he will ask you in the multiple choice question, so you need to make it simple for what? The SI base unit. So now we will add kilogram meter second -2 for Newton. Then we will add meter -2 and also second. Now kilogram. So meter -2 will give you meter -1. Second minus 2 second, it will give you second minus 1. So now this is what? This is the unit of this SI base unit of eta. If he asked you in what? In multiple choice. But in case if you solve the question, you will write any one of this unit only. Don't write this unit. Okay? Now let's move to the viscosity. Viscosity is what? Is a property of a fluid, like liquid. It will what? It will show if the object is flew fast or slowly. So the viscosity of a fluid can be thought of as its thickness, or how much it's easiest flowing. Fluid with low viscosity like what? Like water, are easy to pour, while this high viscosity like what? Like honey or ketchup, it has a high viscosity, so it will be difficult to pour. Okay, it will move. Okay, it will move what? It will move slowly. Okay, now coefficient viscosity again. What is the symbol? It's eta. A property of the fluid. This is the definition. A property of fluid at a given temperature, because it depends on temperature. That indicates how much it will resist flow. The rate of flow of fluid is inversely proportional to what? The coefficient of viscosity. So high eta, it means what? High viscosity. So now it has a low rate of flow. High viscosity, a low rate of flow. Low viscosity, high rate of flow. It will move fast. Okay. Now, drag force at terminal velocity. What it means? Drag force at terminal velocity. So we will talk about Fd when the object is falling or moving up with a terminal velocity. We said before, terminal velocity, it means resultant force equals 0, or force up equal force down. So what it means, if the object is moving down, sphere falling. So now it means weight with equal upthrust plus drag force. So now we have W sphere equal drag force plus U. Okay? Okay. And what after that? We have weight. Weight of object equal what? Equal rho object multiply V object multiply G. Okay, and of course V object, which is V sphere, we can write it as V sphere instead of V object. Can write it as V sphere equal 4 over 3 pi r cube multiply G. And because the sphere is totally submerged like this underwater, okay, so we can say upthrust equal what also? Rho liquid multiply V object, because now V sphere equal V liquid displaced multiply G. So it will be again multiply rho S. Now it will be the volume is again 4 over 3 pi r cube multiply rho liquid multiply G. Okay, so now we find the upthrust force and weight. Okay, let's move to the next. So now we have finished this part, and also we have finished this part. Now, as I said, if D is given, so if you want to find, we said WS equal FD plus U. So if you want to find FD, you have to subtract WS minus U. Okay, this will be FD. So now you can write FD equal 4 over 3 pi r cube G. This is a common factor. Rho sphere minus rho liquid. You can write it in this form. Okay. Okay, you can find the drag force in both equations. It can be calculated by 6 pi eta r v terminal, or Fd equal 4 over 3 pi r cube G, or rho S minus rho L. Now what if you want to find terminal velocity? If you want to find terminal velocity, you need to divide. So now we can write it as Fd again equal 4 over 3 pi r cube rho L rho S minus rho L. We can write, instead of F, we can write what? 6 pi eta RV. So if you want to find V terminal, you need to divide by 6 pi eta R. After that, we can remove R with R cube. It will give you what? And also pi, cancel pi. So it will be 4 R squared G rho S minus rho L over what? Over 18 eta. Okay, so you can also cancel out pi over pi. It can be written as 2 over 9 r squared g rho s minus rho l over 9 eta. As you see, what is the relationship between viscosity and the terminal velocity? Inversely proportional. So as viscosity increase, V terminal will decrease, so it will be like. And also, what is the relationship between the V terminal and R squared? It's what? It's directly proportional. So as R increase, V terminal also increase. So this is what? Directly proportional. You have to know all of this. So if we use a large sphere means large diameter means large radius. So as you see, V terminal, if radius increase, V terminal will be increased. Okay. Now, what is the relationship between the terminal velocity again? So directly proportional to the square of the radius. It means if radius doubled, it becomes multiply 2. The V terminal, it will becomes multiply what? 2 squared, which equal 4. Okay, so it will be 2R, but this will be 4V terminal. Okay, it will be 4V terminal. Okay, now let's move to the next. Okay, let's move to the next. So I can write finally, in this case, if D equal WS minus U again. So can write FD equal what? 4 over 3 pi r cube g rho s minus rho l. Now we can find V terminal, as I said, it will be the same pi r cube g rho s minus rho l divided by 6 pi eta r. We can cancel out r and the pi with this and this, so it will give V terminal equal 4 over 3 r squared g rho s minus rho l over what? Over 6. So I can cancel out 3, and it will be 3 multiply 6 equal 18 eta. Okay, so this is why we said inversely proportional. In the other side, if we want to find what is the viscosity equal, we can write the same 4 over 3 pi r cube g rho s minus rho l, but now over 6 pi r v terminal. Okay, we just replace eta with v terminal, so now we can write the same 4 over 18 r squared rho s minus rho l V terminal. Okay, and also we can make it simplified, more simple. It can be 2 over 9 and R squared rho S minus rho L over V terminal. So this is all the relationship you can write if you ask. Now we will talk about understanding viscosity and Stokes law. So we have conditions for Stokes law equation. Okay, what is Stokes law again? Ws equal U plus F drag. Okay, to gain this relationship, we need what? We need these conditions. The flow of the object is a laminar flow. What's the meaning of laminar flow? I will show you what is the meaning of laminar flow. And the object must be small, so we need a small sphere, and it must be spherical, so we can't use a cube, for example. And the motion between the sphere and the fluid must be slow, so we need low V terminal. And of course, for Stokes law, we need terminal velocity. The object mustn't be accelerating, for example, or decelerating. It must be moving with a constant velocity. Now we will move to what's meant by laminar and turbulent flow. So, again, laminar flow is one important condition to gain a Stokes law. So, laminar flow, as an object move through the fluid, or fluid move around the object, layers in the fluid are created. So now we have a layer of the fluid. Okay, so in laminar flow, all layers are moving in the same direction and don't mix. This is a definition of what's meant by laminar flow. So as you see, there is no mixing between the layers, and all layers is moving in the same with the same velocity or in the same direction. But it tends to happen for a slow moving object or a slow flowing liquid. So we need a slow moving object to gain what? A laminar flow. But this is why for a moving slowly for cars, so we sure what? This is a laminar flow. What for the equation above only applies the laminar flow. Okay, now the turbulent, the opposite. Turbulent flow is the layers move in a different direction. As you see, this layer is moving in this direction. The object is moving in this direction. This one is moving in this direction. Okay, so now in different direction, and also it do mix. As you see, it's mixing now. Okay, this is the difference between the laminar flow and the turbulent flow. So now changing in viscosity, as I said, viscosity is what? Is dependent, temperature dependent, so it's a change with temperature. As temperature increase, viscosity what? Decrease, inversely proportional. Inversely proportional. Okay, for what? For liquids, but the opposite in gases. So liquids are less viscous at temperature increase, but gas more viscous as temperature what? As temperature increase.